Okay, here's the 8th problem in our series worked out. I've actually got this one already worked out to save a little time. F of x equals 4 to the power of 3x plus 5. So we want to see that the last thing we do is raise the constant base 4 to the variable power 3x minus 5. So if we let u be the variable power 3x plus 5, we're taking the derivative of 4 to the u. Then this is the exponential rule, so that's log of 4, natural log of 4, times 4 to the u, times the derivative of the u, because we did a substitution. The u is 3x plus 5, so that derivative is 3. So we can write this as 3 times ln of 4 times 4 to the 3x plus 5. So if you look, it's actually just a constant multiple of the original function, so it's a vertical stretch of the original is the derivative. So if we take another derivative, it turns out to be a further vertical stretch. So we're taking the derivative of the 3 ln of 4 times 4 to the 3x plus 5. Well, the 3 ln of 4 is a constant, so I can bring it out front and take the derivative of the 4 to the power of 3x plus 5. But if you remember, that was our original function we were taking the derivative of. So I can just take my previous result and replace it by this derivative, replace this derivative here by that answer. So notice we have 2 3's multiplied together, which is 9, and 2 log of 4's multiplied together, which is log of 4 squared, times this. In fact, every time we do another derivative, we're just multiplying the old one by 3 times natural log of 4. So these are, each derivative is just a vertical stretch of the one before. If we plug in 1 in the place of x in the original function, 3 times 1 is 3 plus 5 is 8, so we get 4 to the 8th, which is 65,536. Just pulled out my calculator for that. If I plug that 1 in f prime, I get the point, well, this is still the same 65,536, but I multiply that by 3 and get 196,608 times the natural log of 4. So I can find the formula for the tangent line. The slope is this 196,608 times the natural log of 4 times parentheses x minus the 1 plus the y-coordinate that goes with the 1 of 65,536. And I have it graphed as well. Here is the graph. And so the graph here, the original function in blue, you can see graphed. The derivative in red, it's a vertical stretch. The pink, or purple I guess, is the next one, the second derivative. And then at 1, when x is 1, you get this point here, and we see the tangent line. And so that everything looks right. Of course, this is basically just like kind of like a regular exponential. In fact, it is an exponential, really. It's been transformed a little bit. And then these are also stretches of an exponential, so they all kind of look the same basic shape.